got put with all the papers, and it just got sent off.
That's funny.
Sent off into the grade book.
I just plug in, you should just plug it in.
Look how both these things are like different.
Okay, kids, title of this today is 8.3 vectors and what, kids? Okay, now the thing that we're going to talk about today is very much like 8.2, but now there is an XY axis along with what else, kids? And let me show you what this looks like here. It's basically like 3 dimensions right here. So
Yeah,
guys, this is still considered which axis right here?
X.
Okay, this would still be considered your x-axis. And this would be considered your,
Y.
and then like z-axis, anything that's like coming forward at you, that's a positive z value. What if something was like going back in?
Negative Z.
Yeah, so there's like an x, y, z axis here now. But really, instead of talking 2 dimensions, we're talking about how many here? 3 of them, absolutely. Talking about 3 of them. And really, kids, not much different than anything we've done here in the past. I think we've seen x, y, z axis before. Is that true?
I have not.
Yes. You have not one, now you know. Okay. So if I was plotting a point in here, like a point, say 1, 3, I don't know, let's go 5. How's that sound? Okay, I'll go right 1, up how much? 1, 2, 3, and then out towards me how much here?
5.
So it's kind of a weird thing. I'm kind of coming out here, so it's like out. It's like going diagonal, isn't it?
Yeah.
Now. So it's like going diagonal 1, 2, 3, 4, 5 out towards me here. So this is 1, 2, 3. I'm going to go out here first. 1, 2, 3, 4, 5. Over 1 and up how much, really? Kind of like right here, then, where your point would end up. Yeah. It's different. It's very different. Okay. So, kind of think about this instead of ordered pair, you've got an ordered triple now, right? Okay. So, like I said up here, like 8.2, but now there's going to be considered a z-axis in this. So I'm talking about 3 dimensions. So 3, 7, 5 means right how much?
3.
Up
7.
and out
5.
5. Okay? And that positive 5 means it's coming forward to us. All right? So kids, here's the question. It says find the ordered triple that represents the vector from 5, 3, 1 to 6, negative 4, negative 2. Well, it's very simple to do. Okay, where are we starting at? Where do we end at? So your vector formula for finding a vector that represents a vector from one point to another one is your endpoint minus your what? Okay, so if I do my endpoint minus my start point here, well, where did we end, kiddos?
1, 7, 3.
Okay, yeah, you're pretty much on the right track here. Let's do it with both the points up here so we get to that answer right here. Guys, where do we end at? What coordinate now in a 3D plane or a 3D 7? So if I did the 6, comma, negative 4, comma, what was it, negative 2?
Yeah.
Minus, what was the start point, kids? 5, 3, 1. Yeah, a vector that represents that right there from the start to the beginning would be, what is 6 minus 5, kids? 1. Okay, what's negative 4 minus 3 more? Are we good on the second part of this?
Yeah.
Okay, and then how about negative 2 minus 1? Okay, so this means from start to end right here, you go right 1, down how much?
7.
And then when I go out negative 3 or back negative 3?
Back.
Okay, makes sense, yeah? And sometimes I call that out like forward or backwards, like forward towards you or back into the it's kind of like a depth thing, okay? All right, so guys, how do you find the magnitude of that vector? The magnitude being the length of it, right? So find the magnitude of the previous vector. Well, what was your change in x right here, kids? What was your change in x? What was your change in y? What was your change in z? So my friends, we really have to apply kind of Pythagorean theorem, but instead of doing 2 values, you're now dealing with the magnitude is just like 2 space with 3 dimensions right here. So the magnitude of that vector up here is going to be the square root of 1 squared plus negative 7 squared plus What's negative 7 squared? So this is 1 plus 49 plus, what's negative 3 squared? Okay, and what do we get up there when we add those values? 8, so the magnitude has to be whatever the square root of 59 is. And that vector would be the square root of 59 units. Right? All right? You guys good with that? So anything really different here? No, we're just adding another direction, aren't we? Right? We're adding another direction, and this is going to be depth. We talked, X and Y kind of represent length and width, but the z-axis is going to kind of represent depth for us. Okay? So here's an example for us. Let's talk here, kids. First things first, would these be considered rectangular or polar coordinates? If I was doing polar coordinates in this right here, I have a question. How would you do polar coordinates? Would you do it in a circle or something else? Be a sphere, because it's a three-dimensional circle would typically be a sphere here that we talked about, okay? All right, so let's talk about this right here, okay? Find the examples here. So the first one right here, suppose that A is the coordinate 4, negative 1, 7. What's B equal to? Okay, are these written like they look like polar form, or are they written like they look like they are rectangular? Yeah, this is kind of rectangular form. Is rectangular form something that makes us happy or sad?
Yes, very happy.
We like rectangular form, right? Rectangular form, we're happy, happy, happy. Okay? So let's talk about this. We need to find A plus B. So let's see what we can come up with here, kids. A plus B, anybody want to take a shot at it?
What's 9 plus 4? 13.
13, comma.
10. Okay, Christian.
13, 10, 4, right?
Yeah.
You guys okay with that?
Yeah.
And how about a volunteer for B minus A? So we would take 9 minus 4 is 5. 11 minus negative 1 would be
12.
And then negative 3 minus 7 would be. If I come back here and say, okay, once you figured out a vector that represents, I should say an order triple that represents a vector from start to end or whatever these operations are, could you find a magnitude of those now? Yep, you would do the square root of, like in this first one, you do the square root of 13 squared plus 10 squared plus 4 squared. Okay. What's 2 times 8 going to get you?
8.
8.
Negative 2.
Negative 2. Okay. And I do that all the time when I'm dealing with these right here. I forget that there's a third one there. And what's the last one? 14. Very good. Okay. You might want to take a shot at the last one. 2b plus a.
Yeah, it's like it's on you, Christian.
So 18 plus 4, right? That's the x component of the vector. 22.
21.
All right, so 2 times b would be 22, right? Plus a plus negative 1 would be 21. And then what's 2 times negative 3 here? Negative 6 plus 7 would be what? Okay. So anything really different there when we start doing operations between vectors? Not really. So again, dealing with 2, you're dealing with how many values now? Okay. As we talked about this, how do you take a vector and write it in unit form? Or unit vector right here. This would have been 4i minus. What do they represent? The further the depth value with? Okay, so I, J, and K can represent this. So if I gave you this, if I said, suppose you have this, I don't know, 3i minus 5j plus pi k, like this.
Wait, what?
How are you going to write that?
3 negative 5 5.
So 3 comma what?
5. Oh, he's writing.
Right, so you're just going to put it in ordered triple form like that. Okay.
Do you really just like take out the letter or symbol?
Yeah, pretty much.
Pretty
much. All right.
fine.